Good morning, everyone. Good morning and welcome. Welcome to the day three, folks. Good to see a lot of you are back from the previous sessions that we have had. So today we have two modules on contrary of the other couple of days. As I said yesterday, today we're going to cover two more modules and tomorrow another two, and that will wrap up our theory. Remember that we have an exam preparation session on Friday that we will be taking care of. So that's part of the deal. Important, my friends. I would like to be really honest. Compared to what we have done up to this point, the content we have today it's quite extensive. So I'm gonna be sharing with you this tomorrow. So please be sure to join. But this is a solution to yesterday's exercises. You can see here the non-relational with the different types of storage and the access tiers, the type of files per storage. And then we have here the relational study with SQL, Redis Cache, and Cosmos. You can see here the two applications and their redundancy. And we have here the application for 2 days. So now that's a sneak peek. You saw there a little bit of what we will use. And well, we'll use these two on today's session. Okay. Again, I'll be sharing this today. Let me see, because I think that's me. That's me. Just give me 1 second. Let me be sure that we can see it there. There. Yes, there it is. Okay, so I'll be sharing this with you, this file tomorrow. Okay, we're not gonna go through the file right now because we have a lot of content. So I'll be sure to give you the copy of these solutions by the end of tomorrow, so you can have all the solutions for all the modules. Okay, this is the non-relational, and this is the relational solution. You can see here SQL and all that stuff. Okay, so again, we're not gonna take a long time here because of the complexity of today. We have a lot of content. Compared with the previous days, we have twice the content on the same amount of time, running on the same time. So it's gonna be a fun day. So let's get ready, folks. We're gonna get started first with the module number, let's say 3, according to the plans of the week. It's not actually the module 3. It's something like module 6 or 7, but it's part of what we have on the cloud week. And today is focused on the architecture solution for applications. Okay, basically what we have today, my friends, it's an option or a module, if you will, that will be tomorrow, Max. I'll be sharing the answers tomorrow. At the end of the day, I'll put them on a shortened link so you can all access and download a copy. Okay. So the content that we have today, folks, it's applications and authentication. Okay. Those are the two topics that we have. The first one, folks, is about the applications. Take a look on this. It's about using some solutions and understanding some others, because all of them together are part of a single big picture. Okay. Remember, this is an architecture class, not an application class. So we are not going to get into development. We won't get into advanced management or something. It's all about the best practices of architecting a solution. Okay, so the first thing that we have, folks, before we get into the actual application, are the message managers. What are the message managers, folks? A pretty common scenario, something that we all have faced, is that we have a new solution, we have a new application, we go live with the best hopes and expectations, and we realize we get more traffic than whatever we expected. And that usually comes and collapses the solution, right? You were expecting to have 3,000, 4,000 requests per minute, and you get 10, 20,000 per minute. What happens? The application collapses. Or we have peak hours. We get the 3,000 per hour, but on Fridays, morning, let's say 8 to 5, we get up to 20, 25,000. What options do we have, folks? We have different solutions in Azure based on different services that we can put together to control how the applications will be invoked, will be summoned, and how will we deliver the messages and the objects that we are getting in the middle, the events, the messages, etc. For example, what is an event? An event, folks, has a publisher and a subscriber, something that initiates the event and something that will be directly summoned or affected by the subscriber. Okay? These are ephemeral. This means that it's executed once and that's it. It's not actually handled like saved, stored, and used again, or it's not actually something that will take place multiple times, being exactly the same situation. An event is something that happens, like a petition, like a request, like a click, like a message, that will be triggering something, targeting something else. We will see the actual details, don't worry. But it's important we get these two scenarios. The message, folks, has actual information. Okay, the message has I don't know, a user, a password, a pointer, an identifier, and goes straight into the target, the application, the database, and uses that information to perform an action. So take a look on the difference, right? The event could be my click. The event could be my request. The event could be my summoning, my invoking. The message has actual information. Let's keep those two in mind because we're going to use them right now when we start like thinking about the solutions. Now, when will we use one or the other, and what types of services we can use on each? The first thing that we can like, or we should understand is the message. The next slide might look familiar. Remember yesterday when we were going uh, through the storage account services, and I said the QE is not listed on today's class, but it's here as part of the service, right? Well, the message QE, folks, is a message handler. A message QE receives one petition, and there is one petition out. Okay? We have a stack processing. That means first in, first out, FIFO. If we get 100 transactions and we have the capacity of attending 50, we will have another 50 in the QE. And we will be attending each of them first in, first out, as soon as the application is ready to answer. The idea of using the QE storage, folks, is that we can decouple the front-end petition service and the back-end attendance service. And we can have hundreds, thousands, or even millions of messages waiting to be responded. This one, folks, is the, let's say, simplest option available in Azure. It's the easiest one to deploy, it's the fastest one to deploy, and the easiest one to manage, to connect, to drop to the backend. On contrary of the other two that we're going to see in the next slide, using a QE storage, folks, comes in hand as a dependency of a storage account. You need to create a storage account to use a QE. There is no way you can use a QE without the storage account being provisioned first and ready to be used. So once you have the storage account, let me show you here. We go to Azure, portal Azure. Here it is. Once you go into Azure, folks, you go to the storage account. You can go to the QE, create a new QE. Let's call this QE 305. And we're ready. This is how we're going to connect and we can put it in the middle between an application. We can open our QE here, and we can add, if we want, an access policy here, or we can modify the backend metadata. That's all we can do directly in here. Okay? The next step of usage is connecting the front end and the backend, but that is done directly from the services, from a front end web application, from a backend web application. Okay, so we need this first. This is inside of the storage account. Okay, this is the simplest option. There are two other options that are actually quite different than the QE. Take note of this, folks, for the exam. The QE, it's a single dimension QE. One single level, one entry, one output. On the service bus, being our other option, folks, we can have QEs and we can have topics. Okay? The service bus can be multi-dimensional. That's the difference. The service bus is a dedicated service. Ahmadu, yes. Great. Thank you for the question. Actually, that's a pretty important question. What type of storage account do we need? A general purpose. You cannot use a dedicated blob or file share because you won't be able to use a QE. The QE is only available on the general purpose storage account. Okay? Thanks for the question. So as I was mentioning, the queue is flat. First in, first out, single line, and that's it. When we need to have a multidimensional solution, we can use a service bus. The service bus, folks, will actually have one input, but we can have multiple outputs. Okay? The service bus is a dedicated message service. So think about the first one, the service bus QE, the first one we have on the left of the slide, as a single dedicated service to replace the QE. Instead of using a storage account, we use a dedicated messaging service. Okay? A little bit different from QEs, a little bit of a difference, is that if the receiver is not ready, the messages can be kept alive or extended for long periods. The QE waits and drops, and it's always there, like in constant movement. The service bus can actually be like, let's not say perpetual, but a long-term retention for messages. Okay, so the idea of using the service bus here, folks, for example, is that we have the option of, besides decoupling the services, extending the solution or extending the scenario for availability. Okay, so I'm decoupling to don't have dependencies on one on the other. I also have the chance, I also have the option of creating a validation spot where, hey, the last message on the QE, let me get here my pen. My last message on the QE is waiting for the receiver to be ready. Okay, so the idea of using the service bus is that we can actually extend and use a dedicated service, right? That's actually quite important. So that's one of the things we have. The other thing that we can do with the service bus is, and it's one of the like highlights of the product, is that we can use topics. The topics, folks, are pretty useful because we can have multiple deliveries. Based on the content of the message, we can determine which of the possible objects or the possible outputs will be used. Okay? For example, real example, in the bank where I was working, some of you might remember if you were here on Monday when I presented myself, in the bank where I was working there in the UK, we used to have different products, right? Like every bank does today. We used to have products related to financial services like personal loans, group loans, credit cards, debit cards, special gift cards, mortgages, car insurances, etc. We had a lot of things, like maybe 10, 15 different products. We had a front-end application for the users to pre-authorize themselves. You will get into the web app, you will capture your personal information, financial information, and a pre-calculation will be performed in real time. And you'll get a pre-authorized amount of money, credit, or service. Where was the service bus there? Based on the model of product you selected, every single request will go to the same QE on the same service bus. But we will sneak peek into each of the messages. That's one of the features of the service bus. You can sneak peek to all the history of messages. We will determine with one or a couple of variables what type of product you wanted. And if you wanted a personal loan, you will go here. If you wanted a credit card, you will go here. If you wanted a mortgage, you will go here. All the messages will be cached and then distributed based on topic to different type of receivers. Okay? So the idea is that we can send directly to where we need. Okay? What happens, based on the question, what happens if we want the message to be received in queue? This is possible. It's not easy, but you can manually, obviously with an automated service, you can duplicate the message and deliver it simultaneously to 2 different receivers or more. Okay, it's an option. It's not an easy option. It's not like an out-of-the-box feature. You have to do some configuration, but yes, it is possible. Okay, so that's actually useful, right? So that's one of the options that we have. Another option that we have with the multiple topics, folks, is that we can balance the traffic even if it's for the same purpose. Think about this example. I have a customer, I've been working with a customer these days that actually dedicates their time to provide some kind of like advanced product services. They offer like consulting services and taxing services and stuff. They're pretty complex, but they have so many users and such a huge demand of their products that they create instances of the same application. So we use the receivers not as different topics, but as different instances to balance their solution. This is not a balancing option. Let's not get it wrong, okay? The service bus is not actually meant to be used for balancing. We have options for balancing, but they use this to replicate the messages or distribute them across a couple of similar topics with similar functionalities to provide the best option for the end users. That's another possibility, if you will. Using multiple topics, folks, will determine obviously the time of response and the time to leave of a message. You can have a message for a few seconds, you can have a message for hours. At the end of the day, what you're trying to do here, what you will like to achieve with this type of configuration, it's to avoid the end user or the end consumer been waiting for a long time, talking about computing time, and the backend service being completely optimal for the responses and transaction management. Okay, so this is an option that we have for the applications. This is based on the messages. Okay, if we compare the solutions, folks, the QE you can see here, it's based on a storage, so we need a storage account. Okay, it's like quite plain, as I said, a single dimensional QE. Okay, and it can be used for pretty huge, maybe QEs that won't have dynamic allocation, multiple choices, or advanced management, for example, with sneak peeking, topic creation, etc. Okay, so that's one option, the QE storage. The service bus, you can see, has a service level agreement that is 99.9. and it has always first in, first out. Important. Let's be clear. The QE storage also has FIFO, okay? But given that we're using a storage account availability, that might not be guaranteed. The first thing might have failed due to a failure of the storage tier, of the storage account, okay? While the other, let's say on the service bus, we actually have that option. We always have the pick lock and the actually automated deletion. These two, the QE folks, I don't want to badmouth the QE. I don't want you to get a wrong idea. But the QE is not optimized for heavy duties. So if I, end user, click twice on the form, I might have two messages, right? I need to manually or create an automatic process to clean the messages on the QE. Okay? So I need to do something manually so I can clean and guarantee uniqueness. The service bus has that by default. If I get a message, I'll check if there is a replication and I delete that replication. And if I only have one, or I can only find one of those messages, I'll pick lock it and it will always be guaranteed. So even though we can achieve the same with both, the service bus has this like intrinsic to the same solution. Okay, you can put multiple batches of messages as one single transaction, pay per transaction, or optimize per transaction. Okay, the messages are actually pushed. The QE folks has to be pulled here. On the QE, we have to actually use the receiver at the end of the QE to pull and pull into the receiver. The QE, it's always waiting for, let's say, an authorization or a request to process it, while the service bus is constantly pushing, trying to get the messages served as fast and as immediate as possible. Okay? And remember, the service bus topics is many to many. That's the main difference. Many inputs to many outputs. That's it. This is the idea of using the different messaging solutions. Okay? Now, how are the messages being handled when they fail? The service bus and the service bus topic can create a time to live extended based on a failure. If the message failed to deliver because of an issue on the receiver, on the destination, the same service bus can actually recreate or extend the leasing, the time to live. You have configuration for that. It's out of the box. You can select a couple of indicators there on the message view and say, hey, keep this one alive and retry again in X amount of time. Retry 5 times, and after that, maybe drop it. Okay? That's an option. While in some other cases, you might just want to try it twice and then drop it, or kill it and create a log entry, or kill it and register an exception or a notification, right? This is automatic on the service bus. On the QE, a lot of them might drop, a lot of them might actually fail, and well, we might need to create an automatic way of logging so the action can be triggered and registered a failure. So again, I don't want you to think that the QE is useless, okay? That's not my intention in here. I really want you to see or to understand that the QE, it's useful for simple scenarios. Testing, development, quality assurance, even for production in some reduced scenarios. Nevertheless, if we want to have a complex and advanced solution for message management, the service bus is our actual goal. Okay? So this is the first one, the messages. Again, we have two topics today. The first one feels a little bit more theoretical because of the amount of information without demos, but I'm trying to bring some of the questions into the discussion. The questions, if you don't see I'm actually answering all the questions. We have our moderator answering some of them, and I'm leaving some for the next topic. So don't feel that I'm ignoring you, okay? We actually have our moderator, Joyce, answering your question. So these are the messages, folks. This is not a mandatory, but a pretty important option to go when we decide to use a proper design of applications in cloud. Okay, we can create a full application solution without this. Don't think that it's mandatory. But hey, if we can decouple, if we can extend the SLA, if we can optimize the user experience, and we can reduce the overhead management of our application, of our solution, why wouldn't we? Right? So it's an important one. It's an important part of our business as usual. Now, the second thing that we have, folks, are the events. Remember the first slide, we had messages and events. Well, the second thing are actually events. Okay, just give me 1 second. Let me see how our times are going. Here we are good. Okay, so the next part is about using different types of triggers to initiate a sequence of events. We have, as we saw, the service bus, and we have now something called the event hub. Okay, what's the difference, folks? We got that question on the chat, and don't think, Antonello, that I was ignoring you. I was waiting for the topic to open to the discussion. Okay, the event hub, folks, is a platform that handles big data. Let's keep it as simple as possible. It's an ingestion service, okay, that will catch streams of data from a lot of different sources, okay, to execute a sequence of events. What's the difference? The main difference, let's say, between the event hub and the message queue. The event hub, folks, can be any type of action that requires attention or requires a reaction. The message includes data. That's the main highlight. The message includes data that the application requires to process the actual transaction. The event hub can be just a click, can be just a bit or a byte, can be just a 1 or a 0. Okay? The idea of using the event hub, folks, is that we can catch, or we can actually receive any type of generator, any type of producer, and then execute a massive processing simultaneously. We are the ones who define the type of event that we're expecting to happen. For example, think about your company wanting to monitor all the different tweets related to your products using Twitter. Well, I don't know if Twitter will stay alive after what's happening, but let's keep the hope. Let's say that Twitter survives all the changes it's suffering, survives all the things that are happening, and we have Twitter ready to be used in a couple of weeks. And we want to monitor everything that happens in Twitter related to my product, to my brand. That's possible, right? How would you catch or monitor hundreds of thousands of tweets per second if the tweets are not actually pushing into a queue? We don't have someone pushing the tweets manually. We cannot use a service bus. The service bus is not intelligent. The service bus is waiting for something to be triggered, right? How do we do that? The idea, folks, of the event hub is that we can use sensors. That's actually based on artificial intelligence and cognitive services. Sorry, I forgot the word. Cognitive services to catch them. But the event hub, for example, will use an MQP or will use an Apache Kafka app to drop everything into subscriptions, into event hubs partitions. The idea of having partitions, for example, is that we get a real-time streaming and we can handle thousands, even millions of events simultaneously. And then we start dropping the objects. We can use advanced analysis and advanced monitoring with an event-driven solution to say, hey, these tweets look, okay, these tweets look like a good sentiment tweet. These tweets, on the other hand, are actually, or look a little bit off. They look like attacking, or they look like negative comments, or they look like angry people. That's actually possible. I mean, I'm talking about how do you trigger the actual consumers. You'll say from 1,000 tweets that I have, 600 are good tweets, 400 are bad criticism. You can send them to different event receivers. The good tweets might be sent into a database to create a dashboard report of what we're doing good, and the bad tweets might be dropped into a log analytics service to trigger an alert and send a message with a summary of the bad tweets to a real user dealing with customer service. Just an example, so you can grasp on the content. You see the difference between this and a message, right? The message triggers something that will need to be automated, and we have data to process it. The event hub is the actual tweet. The content of the tweet, it's something that we might or we may not need. And we have hundreds and thousands of processing lines and threads simultaneously working, real time. We might need a pretty heavy throughput on overnight and weekends, and we might have a pretty relaxed throughput on Mondays and Tuesdays. So it scales. We don't define the topics based on that demand. We actually we're ready for everything. Okay, so that's the idea. The idea of using the service bus, the idea of using the event hub, is to handle multiple transactions. When are we going to use this over the service bus? That's one other question we have on the chat. We will use the event hub when we want to design a solution based on events. When our solution is driven by the events. Okay? The event grid uses the event hub. When we will use the event grid or the event hub? When we actually need to have a lot of different front ends, a lot of different options to generate. Okay? Think about this. We have Raspberry Pis. Okay? We're receiving bits and bytes from Raspberry Pis. We have a monitoring service watching for our tweets or the tweets related to our product based on keywords, not on accounts. We have a streaming service that feeds any type of feedback from the users. We have a couple of storage accounts that we're actually using to catch the subscription images or the subscription files of the users. We have topics triggered by the service bus. All those things, all those possible actions are considered events. We will use those because any click, any file being uploaded, any log being registered, any computer or virtual machine being created is an actual event. That's the difference, folks. It's not that complicated. The message has data. The event is an action, any type of action, with or without data. If we need our applications or our solutions to react to those actions, folks, we actually use an event hub or an event grid. The grid is multi-dimensional, and the event hub, it uses multiple events. But that's what we need to remember. What am I doing for the application to work? Let's give you an example. Let's say I release a new application today. I create my own solution for streaming services. I'm gonna send you that. If you subscribe, okay, if you subscribe, you will have to share some information, right? User, password, I don't know, credit card, a few other things. I get that, and we're good to go. We have a message. We can use a message for the subscriptions. Every time you click play on a movie you're watching, I'll get the time that you left, where were you on the movie, okay? And I'll be able maybe to determine with that data, with another message, that you were watching a movie and you left here or there. How do I analyze the trend of watching that you have, the multiple users on your account, and the things that I will suggest to you? I can use all the messages, create a copy of the messages, and then manually, manually, let's say with a machine learning algorithm, analyze your preferences, right? We got messages for you to subscribe, for you to start something. But how do I identify the things that you like? How do I suggest to you, or how do I keep you engaged with my product? Think about any streaming services you might use today. If you say, I don't like this, I like this, I click on this, I only watch 3 minutes of this, or I watch the 10 episodes of this one, and I keep watching and watching, and I have multiple users on my subscription doing the same, all those things are eventful. We cannot use a message because it's not something that I will usually recommend, right? I'm not going to create copies of the messages, feed them into machine learning, and then do something about it. No. Every time you click on something, every time you click like, every time you dislike, every time you pause, every time you start, you create an event that goes into a database or that goes into a big data solution. Okay, after a week, after 2 weeks of analyzing the behavior of Arturo on my new application, I can determine he likes to watch horror movies, for example. So I start suggesting based on those events. I cannot use the message because the first movie he watched might have been 3 months ago. I will have had to create a copy of the message and execute a complete backwards analysis. This is a real example of both working together. Okay, we could do it only with messages, but that will be 100 times more complicated than registering just the event in a grid or in a queue or in a message. What would you do? Think about the event as anything that happens, folks. Anything that takes place in your subscription, in your sensors, in your front ends, with or without data. Something that you'll catch to trigger something else. Someone starts the computer, a virtual machine. You may have information about the time of start, the name of the application, the user, the operating system. You might save that for some purposes. But what you actually wanted to do is to start a notification process when a computer is started. Do you actually need the data? Will you create a message with a complete PowerShell script just to drop the notification, or you'll use the event of computer started to trigger the notification? Think about that, folks. That's the best way to understand when to use one or the other. Do I actually need the data to process something? The event includes data that is relevant, critical for my business process? If the answer is yes, that means that we might need a real-time response, we might need a real-time processing, or we might need a data management solution, a backend application. Let's go for a message. I just need to catch the initiation of the computer. Let's go for an event. Okay? Again, it's a little bit abstract. It's a little bit abstract when we haven't used this. That's why I was recommending that if you have the chance, take a look on the 104 on the application management, so you see how to deploy one and the other, and you'll notice the difference. You're catching a sensor that includes data to trigger the message, or you're just watching for an event activity to take place. It's visually available on the services. We don't have the time to do that because we will take 2 hours just building, and we only have 2 hours for 2 modules, right? As I said, but it's a good option, okay, to go one or the other. So we can have, you can see here, the type and the purpose. You can see here what I was mentioning in my examples. When we go for the service bus, we need to process, we need the data, we need a message, okay? When we go for the event hub or the event grid, we're actually catching an event streaming. And as I said, we can use big data. Big data, folks, we don't have that discussion on this lesson or this class, but using the big data part of it, we can actually create a pretty complex solution of hundreds of thousands or even millions of bits and bytes simultaneously processed. Okay, so that's it. Yeah. Yes, Max. That's what I was mentioning. pausing the video and resuming there could trigger a message. But if you see that the user paused the video and never watched anything again, and then he went for a complete series on the next watch, 10 episodes on a different, let's say, product, you use those two events to say, hey, the first one didn't work. And you're not going to actually say he paused, and I don't know if he will watch it again or she will watch it again, right? If you pause a movie and you didn't like, you might leave it there for the rest of your life. That's not something that a message will say for you for the rest of your life, but an event will determine that you never came back to resume that pause. So that actually is used, for example, for the machine learning algorithm to determine that, hey, these type of movies are not actually into Arturo's likeness. For example, I mean, I'm just like giving you a global picture. It's more complicated than that, obviously. It's pretty more complicated, but it includes information for both. Okay? So there is one more to make it even more complicated. There is one more that we can include in our plans, the IoT Hub. Okay, the IoT Hub, folks, it's actually a solution that will include telemetry services, device support. Now we have a variable of device, okay, and the whole process of events and messages. IoT Hub, think about IoT Hub as an event hub based on actions, but optimized for devices. IoT, the Internet of Things, any device that has a way of interacting with the internet and sending information or sharing information will actually get a reference of IoT. Now, you might be thinking, why the event hub cannot be used like an IoT hub? The IoT hub is focused on the actual, let's say, relationship between the action and the device. The event hub is only focused on the action regardless of the device. Okay, so when we talk about IoT hub, imagine that you work on a pretty huge company where you deploy an IoT network. Okay, every shelf that you have for the inventory has sensors to monitor the product replenishment. You have maybe a height, a weight, a measurement sensor. Every aisle, every shelf has one of these. You have cameras to monitor the people going in and going out. The combination of sensors and cameras will actually let you know when you need to replace or to restock, right? You could do that by using an application, inputting a number, and catch a message. Or you could do that every time there is a sale if someone pushes a button, right? I take the, let's say, product, I push a button, we know there is a sale, one less, that's an event, right? An event hub. I don't care the type of button, I don't care if we have sensors. I'm only caring about someone feeding that into my event hub. If I actually want to automate this and focus on what the device, the sensor, is sending me, IoT hub is our call. A pretty small example. In June of this year, there was a pretty big change on the economy, right? We got a lot of changes and still impacting these days. And I had a couple of free weeks. I was quite enjoying myself during my free weeks on June. So I was pretty bored. And I decided to remodel my house. I went for an extension on my office. That's why you hear a little bit of like echo, because I duplicated the size of my office, and I have a pretty empty room. When I extended the office, I decided to go for a larger fridge for the office. So when I got the fridge, I was like, let's analyze the consumption. I bought a small Raspberry Pi, I put it in, and I started analyzing the consumption tracks compared with the small fridge that I had before. Putting the same amount of cans, the same amount of things, I was feeding bits and bytes into the Raspberry Pi and connected to my Azure IoT center. I determined that if I distribute the cans in an efficient way, the consumption is like 10% more, while the size is twice the size. Don't ask me how I determined that, because it took me 2 weeks analyzing the data, and that's my assumption. Okay, it's not. I don't think that is the actual or pretty accurate. But I'm mentioning that example because I was trusting not on the data that I was putting to catch. I mean, the first layer. I have to be pretty sure about the consumption going through the electricity catch that I had on the Raspberry Pi. So my focus was on the Raspberry Pi. After that, the data was a second-hand management option. Think about that. The IoT Hub is actually about the, the functionalities of the device. Another example, Microsoft recently, well, not recently, like 3 years ago, released a statement, not a statement about a project they ran called Cows as a Service. Cows, the milking mammals. They bought hundreds of thousands of Raspberry Pis, and they ran an experiment in the United States where they put a bracelet or a necklace to the cows to analyze their trends, how they behave, the active hours, the body temperature, the body fat, all that stuff. They feed that into IoT hubs as ones and zeros, no readable data, and then using big data, they process that, and they use that information to improve the quality of life of the animals. They were able to predict, maybe not 100% accurate, but 50 to 60% more accurate than just watching them, when they will get sick, if they were getting sick, if they were getting pregnant, if they were pregnant, if they were on heat or made season. It's actually quite a thing. We're talking about usage of advanced artificial management, machine learning, big data analytics, etc. If we're going to have the dependency of the device information being sent, we talk about IoT Hub. If we just care about the actual event, we go for an event hub. Or we just need the data for the real time or the close to real time process on the application, we go for the message. Okay? So these are the three options that we have. Tomorrow, along with the link to the solutions, folks, I'm going to share with you a small drive, a small OneDrive link, where you will find a couple of videos that I got for IoT Hub, Event Hub, Event Grid, and Service Bus. So you can see maybe 3-4 hours of video on differences between them on real demos. We don't have the time because of the way this class is presented, but I think you'll find that useful if you want to watch that on real time. Okay? So I'll be sure to get you those links tomorrow at the end of the class. Okay? So these are the three options we have to integrate with our application. Okay? The next thing that we have, folks, let me see here. Just give me 1 second. Are you here? Let's complete this lesson so we can continue with a small break, a 5 minutes break. And after that, we will continue with the second lesson. So the next thing that we have, folks, is the optimization solution. Okay, so what we have, it's the actual use of Redis. There is a solution in the middle, folks, called the Redis Cache that can be used for temporary or advanced caching. Okay, the idea is that we can catch information, we can catch transactions, we can catch petitions, and we can catch any type of data that will be used for the application to process. Okay, so what I'm mentioning here, folks, is that we have a solution. We have a solution where we can catch for availability or catch for performance. If we see the application, the database, or the front end is taking a long time to process the data, we can actually use a temporary catch to put it closer or to feed it piece by piece to the front end or the consumer. Okay, so it's one of the options that we can use. Now, another scenario that we have, folks, when we use the catch on Redis, I see you're having issues with the connection, but the presenters and the producers are mentioning that they are okay, so there is no lag on their ends. Okay, do you want to refresh the pages, folks, just to so you can reconnect? I'm gonna stop the screen, and if you want to refresh your connection, it might be the same platform on the delivery end because we don't have that issue. So if you want to reconnect, I'll give you 2 minutes and we will continue on this one. Just try to reconnect, folks, please. Yeah, I mean, it's not me because I double check with the producers and they don't have lag on their end. So what I'm thinking is that maybe the catch, they are not using Redis catch for sure. And the catch is actually getting quite laggy because of the amount of connections. So that might be the thing. Yeah, I stopped the presentation. If you're reconnected and you see all black, it's because I stopped the presentation. I'm waiting for everyone to reconnect so we can continue. Okay, let me show it again. Let me see. There. There should be, you should be the screen. You should be seeing the screen now. There it is. Okay, so we were talking about the catch as an option. The final part we have here, folks, so we can get a small break, is about the application lifecycle. Okay, the lifecycle, folks, is actually about automating the deployment and using advanced deployment. Okay, the automated deployment comes from a principle called infrastructure as code. The infrastructure as code refers to you using, you the end user, you the designer, you the architect, you using a method of deployment that doesn't require human interaction. Okay, so for example, the idea is that when you go for infrastructure as code, you have the capacity of executing based on templates, for example, JSON files, for example, automation, for example, DevOps, to deploy your information. If you have ever seen a template, folks, you are capable of using an automated deployment of that template and then just provision the same computer over and over. You don't have to wait or you don't have to stop for the application to be used. Okay, you will keep the deployment continuous without anyone configuring manually the computer or the objects. Okay, now something that we have, folks, that it's pretty common is the idea of standardizing or creating baselines of infrastructure. If you know you're going to use the same type of computer multiple times or hundreds of times, it's easier to have a template, right? You can configure your application solution to use that. Guys, it's not my end, I promise. We don't have lag on our producers. I'm using a symmetric 500 megabytes connection, so it's not on my end. So I don't know. If you want, we can take a break and see if it solves, but I don't think that will change a lot. Let me see here. I'm gonna put a timer so we can take a break, and we'll be back in 10 minutes. No, 7 minutes. So let me see here. Let's go for this one. And there it is. Okay, we're back. We're back, and I know you may still have some issues, but we have well, we are actually going to continue. So this will be on the recording. All of you will have access to this recording, and you'll be watching this. And please forgive us, guys. It's not our issue. It's not my issue. I promise. It's not something on my connection or our connection. It's a little bit of disruption on the platform because of the amount of attendees. So you won't have any issues when you watch this recording. So that was the first lesson, folks. We're gonna go through the review, where we will see the application architecture. You're going to have to create a solution that fits the architecting design of an application by including IoT Hub, by including event hubs, by including triggers, and including the management via queues. Okay, so this was actually our final part of the module 1. We're going to continue here with our module 2, that is now about the Active Directory. Okay, so give me 1 second there. I'm gonna jump into the Active Directory now, so we can go for our authentication and authorization. This is the second and final part of our day 1, folks. Sorry, of our day 3. So what we have in here? The Azure Active Directory, my friends, as a lot of you might know, is one of those solutions that we cannot live without, right? There are a lot of things that we can or we cannot include in our design, but Azure Active Directory is mandatory. Azure Active Directory is one of those things that one or another way will be part of our solution, of our subscription. Okay, let me just do something here. So there it is, and bring it back online. There. So a recommendation when using Azure Active Directory, folks, is that we determine what will be the best option whenever we're working. Okay. When we use authentication and authorization, well, we're going to talk about these options here, but when we talk about authentication and authorization, we are designing for identity. The identity design, folks, refers to the principle of we having or we getting an access management solution that can actually follow the best practices of security and authentication. We have something called the zero trust model. The zero trust model, folks, refers to us or refers to our product challenging everything. This is something quite important because every time you authenticate, your authentication request will be challenged, will be evaluated. If you, for example, take a look in here, if I click Control and I open, for example, Azure again, you can see my authentication is taking place again. This, my friends, is the principle of the zero trust model. We're actually being authenticated or challenged multiple times so we can prove or we can actually be sure that the request is secure, that the request is safe, okay? We are going to do this via identity and access management. There are cases and scenarios where you might need to authenticate with different or specific characteristics for the directory to let you in, right? For example, think about this. What if the user exists on my location? What if the user exists on my company, but the IP they are using is not part of my private network? We can block that user from accessing. So the user is valid, but the IP is not. We have something called conditional access, for example. We have the option of authenticating with a cross domain. You can access my Active Directory, I can access your Active Directory if you want to invite me or I want to invite you. We have business to business, we have business to customer. I'm going to show you this in a minute. The idea of designing for Azure Active Directory, folks, is that we can actually determine the way we will authenticate with our users. Let's have a little bit of a briefing here. The Azure Active Directory, my friends, it's the cloud version of the Active Directory on premises. Easy peasy, right? We have an Active Directory, We have an identity manager, we have services and identities, we have authentication and authorization. We don't need to do anything else. It's pretty straightforward. There are a lot of scenarios where using the Azure Active Directory will actually be simpler and faster than using any other type of directory. Okay? Now, using the Azure Active Directory, folks, will actually let you administrate all the cloud identities. Every single cloud identity that takes place will actually be part of the directory. Users, service accounts, managed identities, on-premises hybrids, guest users, as I said, third-party invites, etc. The Azure Active Directory, folks, will always handle this. We cannot exist or we cannot use Azure without an Azure Active Directory. Okay? Now, when we design for Azure Active Directory, folks, the first thing we have to know is that when we authenticate, we have an Azure Active Directory services. There it is. That will include our unique ID, our domain, you can see it here, and the type of license, the number of users, the groups, the applications registered, etc. We can go here and pretty fast create a user. We can go here and say create new user, and we can select here basic information. As long as we have a username and a name, we can create the user. Easy as that. Okay? So I can go here, for example, I can say Dave McKean, and see what I mentioned. There it is. I don't need any other piece of information. Okay? I can do that at any moment. But this drives me to mention something that is pretty important. I'm deleting this because I want you to see. In the past, folks, and you won't let me lie, in the past, we used to have a tradition of creating users locally for them to interact with me, right? If 10 years ago you would want me to collaborate with you as a consulting service specialist, for example, you will have had create me a user, arturo.hamilton@company.com, okay? And you will be giving me the user and the password, right? I will exist as a local user on your directory. Today, folks, that is not necessary. We can create the users as guests. As long as you and me, as long as we both have an Active Directory in Azure, we can trust each other without an issue. Check this out. I can go here, I can click on invite, and I can send an invitation to anyone with an external directory manager. So I can call this, for example, the name of my consulting company. I can send this to my consulting company. I can click on invite, and I'll get an email in the next 5 minutes saying that I got invited to collaborate as business to business. We are now, you can see, check the difference. You can see here, this is handled by my domain, by my directory. This is handled by an external Azure Active Directory. I don't have to trust that other directory. That directory is trusting me and I'm trusting them. This is an automatic behavior, okay? It's one of those things that we usually will consider pretty important because the collaboration is something that remains like a critical thing between companies, right? So as you can see, now I'm invited. Let me open here my email application, and you will see this in a second. So I'm going to show you here, and let me just, there you can see, it's coming through. There it is. And you can see here, you have been invited to collaborate. I can accept the invitation and I'm automatically considered a guest. Okay, that's the idea of using the Azure Active Directory, folks, that we can reduce or we can optimize some dependencies into cloud instead of creating trust relationships, or stuff like that. That's the business to business, folks. We can also create something called the business to customer. Today, folks, today, it's easier than ever to authenticate into an application using any identity provider. How many times you have been, for example, in in an airport, in a restaurant, and when you try to access their Wi-Fi service, you are asked to authenticate with Facebook, or you are asked to authenticate with Twitter. That's the principle of business to business. We can trust other identity providers, okay? So we can use their own identity handling to authenticate locally. For example, I can create a single sign-on experience. So my user in Azure, it's the one used to authenticate into Twitter. I can send the authentication token of my users to other services so they don't have to create a local user. How many times you have seen the option to register with third-party account, right? 10 years ago, this was impossible. You have to create a local user and a local password. Today, you can register, log in, and authenticate with Facebook, with Twitter, with Google, with a lot of different options. So this is what I was mentioning. This is what it's important, folks. We can now let our users, consumers, and customers to have a direct relationship with our directory without them existing locally in our services. Okay, so that's another option that we have, the business to customer. So when we have business to business, folks, we have the capacity of interacting with other identity providers like Azure Active Directory, as you saw. Your directory trusts mine, my directory trusts yours. Your users can authenticate on mine, my users can authenticate on yours. We cannot see each other users, the users cannot interact with others, but they can interact with the platform. That's what we want. Okay? Your users are managed on your directory locally. You can change their passwords, you can modify the security, and I can do the same on my end. Okay? So that's one of the options we have on the business to business. On the business to consumer or business to customer, we enable multi-factor authentication, we enable advanced services, and we are capable of authenticating with any third-party public provider. At the end of the day, folks, what we're trying to do is to reduce the level of usage or the repetitive management of creating users for a temporary or a one-time access. Okay? That's the idea of the business to business and the business to customer. Now, one of my favorite tools when designing for identities, folks, conditional access. Conditional access, folks, it's a feature that you can use to create rules that you will analyze before allowing. What if I need to use customer ID users properties inside application and database? You can synchronize. We have a question from Maxime, folks, that goes like, what to do if I need to use customers Active Directory users properties inside the application? When you authenticate with a business to business or a business to customer, you can select the metadata and the claims shared by the source, Maxime. Okay? So you can ask the authentication request to catch, for example, specific information for the temporary management. You cannot synchronize two Active Directories, two Azure Active Directories. You can synchronize on premises to cloud, but that's a different story, right? So what I'm saying here is that you do have the chance of using those possible attributes of the user on your local service, on your local subscription. But the user won't be synchronized with the third-party directory, Maxim. Okay? It's important you remember that. So that's one thing. Now, I'm talking about conditional access here. Conditional access, folks, it's a premium feature. Before I continue here, let me give you some context. Azure Active Directory has the capacity of configuring different type of security features and management features based on the subscription that you have. Okay? There is free, basic, premium 1, and premium 2. The free edition, as the name suggests, has no cost. You can get it for testing, for quality assurance, etc. The basic subscription will give you an extended limit of users, will give you some of the basic features and advanced features, and you'll be able to use it for a pretty small amount of money. The premium features will include stuff like this, like the conditional access. The premium features, folks, will give you advanced security. Conditional access policies are about evaluating everything that happens during the authentication request to decide if the user or the context is at risk. What is this, folks? You can use signals of the authentication to say, hey, these conditions are not good for me to authorize you using Microsoft Teams. I saw someone was suggesting that we jump to Teams, right? So let's use that as an example. What if I want my users that have permissions to work on Teams to only be allowed to use Teams if they have a private IP granted by the company, let's say connected to the corporate network, a device that is registered for management, a device that is compliant to my security policies, a location that is known to me, like the office or a specific segmentation, a non-risk detection of his or her user. What if I want to combine all these policies to say you can access? You can access Teams only on the desktop version. I don't want you to use the mobile version nor the browser version, only the desktop. And I don't want you to use anything but Windows 11. I know it sounds silly, but it's example. All those things that I mentioned can be evaluated to say you have the access, you have the access with conditions, accepting the end user license agreement or multi-factor authenticating, or you don't have the access. That's the idea of conditional access, folks, that we can decide every time if the sign-in could be at risk. Think about that. Think about the chances. Think about the options. We have, what happens if I use VPN from restricted countries and try to access? You can actually create a bindable for that. Okay, so for example, if you use a VPN to connect to the to a local network, okay, but the source IP, because that comes also from the source, says that you are connecting from, let's say, Mexico, you can use that option. You can use the Mexican bindable. And I'm allowed to say that because my mom is Mexican and my dad is from the UK. So I can say that as an example. If you're coming from Mexico and the connection comes from Mexico, a country that you consider not allowed, conditional access will detect the source IP of the connection is this. It's using a VPN. Are we allowing VPN? Yes or no? No. Is Mexico a country where we have business? No. Block the access. You can do that, Chandras. Okay? I mean, it's a little bit more complicated because you have two variables for one single evaluation, the IP, right? But we can do it. We can select the application to be registered. Okay? Check this out. Let me show you. I'm going to go for a small demo here. I think that will make it easier. I'm going to use my real subscription. Well, my corporate subscription because I have conditional access there. So ad.portal.azure.com. This is a real subscription. So, I mean, the other one I've been using is also real, but that's just for demos. This is a production subscription. Okay. So, for example, Antonello is asking, what if I want to use this in a third-party application, right? On a line of business or an in-house development? You can do that. You can grab any application you want and use the conditions to say you can use it, you cannot use it. That's the amazing part of conditional access rules. So I can go here. conditional access. I'm going to show you a demo policy. You can call this demo 305. And here it goes. First of all, who will be analyzed or who will be monitored by conditional access? You can select one user. You can select a group of users. You can select an actual role. You can actually say the global admins, the security admins, the user admins. So I can go here and say, everyone, specific users, or specific roles. You see, it's important because you can create hundreds or thousands of rules based on a lot of different scenarios. I'm going to select just one single user, and that will be me. So where am I? Here. I'm going to use this one. There. Just zoom out a little to select it. And zoom back in. There. So I have one user. The next thing is the actual target. I'm going to do this as I was explaining to Antonello. I can select specific applications from a list. You can see here. And this includes applications that you have registered, folks. Registered applications developed or in-housely managed by you. Just for you to see that I'm not lying, check this out. You can see here some of the applications I use. This is Daniel's application. This is a DP class application. You can see here Mapbox. You can see third-party solutions and official solutions. You can see here, hey, my application exists. Sorry, I know some of you speak Spanish, so you can see these are real in-house applications. I can do that, okay? It's not like you have to go for only registered applications of or third-party applications. You can grab official apps, actually. You can go here, say Teams, and then use my custom application. You see? I can apply the same rule for a line of business app and an official Microsoft app. I hope this answers the question, Antonello. So I can click select. I have my apps. And then the actual conditions, folks. I can select different conditions to determine if the sign-in is at risk or not, if it's allowed or not. I want to explain this too in a minute, okay? Just hold that one. I'll talk about these two risks in a minute. It's part of the next topic. But I can select, for example, the platform. I can say you can only access from Windows devices, for example. You cannot use any other device there. You can only access if you are on a trust location, or I can select my location. You can see here, global admin, Mexico, Estados Unidos, and Canada, well, United States and Canada, our office in Montreal, no coverage in North America, etc. Or I can select a specific list of IPs. You can see here, trusted IPs for multi-factor. So I can say here, I want you to use only the desktop client or the mobile client. There it is. And your device has to be, and I can select conditions for the device, folks, advanced conditions. I can select here, for example, check this out, the ID, the compliance, the enrollment, who's the manufacturer, what version of the operating system is the user using, etc. You see, we have a lot of options. Based on those options, folks, let's say everything here is met, then I'm going to give you the access. Some of these are not met, well, we will see. Or everything here is met, I'll let you access, but if you multi-factor authenticate yourself, for example. That's the idea of conditional access. It's that we can evaluate what's happening on the service. Now, if we continue here, so I can go back to the topic, we have something called the risk. You saw, right? The user and the device risk. The risk, my friends, comes from a service that it's premium to, by the way. This is one of the few services on premium too. Premium 2, my friends, includes this amazing service called Identity Protection. That is my favorite services for security because it uses artificial intelligence and machine learning. Identity Protection uses a machine learning algorithm called behavioral analytics. Basically, it evaluates the way you behave as a user to determine if you're at risk. The type of permissions you have, the commonly used objects, the commonly authentication methods, all those things are part of this product. And based on those trends of behavior, it can say you are at risk. Okay? So this specific option, folks, of the sorry, I lost the track of what I was thinking because I was reading the question. This specific solution to monitor, it is used so the same service can call the shots whenever someone seems to be at risk. I'm going to give you two real examples. First one, I used to travel a lot before the pandemic. I used to have, I don't know, 2 weeks per month, an on-site class, most of the times in the United States or Europe. Okay, so the same identity protection service have learned that I usually will be on a list of 20, 25 different countries. My last class on site, the last class I had on site before the pandemic, and that's the last class I had actually face-to-face with my attendees, was in Brazil back in 2020, the first week of March. Still remember that. I was flying back from Brazil to Mexico City, and my connection flight got delayed. And instead of having 3 hours of wait, I had 40 minutes. So I had to run, and I mean run through the terminals to catch my flight. When I travel, I usually wear sweatpants because of being comfortable. But you know, the sweatpants are not famous because of they having pretty deep pockets, right? Usually they are shallow. So while running, I dropped my mobile, and I didn't realize. When I got to the boarding line, I saw I had no mobile. 10 p.m. Friday night, I was like, what should I do? Should I go back and look for my mobile? Or should I get on the plane and get a new mobile? Half of a fraction of a second later, I was on the plane. So that's what happened. That was Friday. Sunday, I'm working on this same computer, the same device that I'm using for the class. And out of the blue, I get blocked. I get a message on the security management tool saying that my user is at risk, and I get blocked. I log in with an alternate account I have for emergencies, and I see that my user is trying to access from Nigeria. I've never been there. I've been in Morocco, I've been in Egypt, the closest countries I've been in Africa to Nigeria. But the service determined that, hey, Arturo has never been in Nigeria, first. Arturo is a global admin, second. Arturo is trying to connect from a device that seems to be using a public IP that has been determined to be at risk, or a risky list of IPs. Third, Arturo is actually accessing from Mexico and Nigeria in a 2 hours period. Physically speaking, that's impossible. Four, if we combine all those variables, we determine that Arturo is on a high risk. That is conditional access. Sorry, identity protection. We can feed that into conditional access. So conditional access can use the risk to say, hey, that's also a thing. So if you want to have access, your risk, let me just select this one. Here you can see the risk. Your risk should be low. That can only be done by identity protection, folks. Okay? Identity protection can evaluate a lot of different variables. For example, another real example, a friend of mine, one of my best friends, he's also one of the trainers in my team, called David. He actually lives like 10 minutes away from my home. Okay, he well, I run a coffee shop on my free time. That's not a lot of free time, but I run a coffee shop on my free times. And the first week I was on business, he spent the whole week on the coffee shop. He was there the whole week. The first day that he went by, he connects, and I get a message on my monitoring tool that David devices is at risk. I start going through the identity protection, and I see that my IP service provider assigned to me a blacklist IP, a forbidden IP to be used, folks, determined to be at risk by Google, by Microsoft, by a lot of companies. So he was not at risk. The risk was for the device. So that's, you can see here, the sign-in risk to be here. So this is the identity protection, folks. The identity protection is a pretty powerful tool we can have or we can use to monitor this type of stuff. Okay? You don't actually call the shots. You will never determine what is a risk or what is not. The only thing you can do is to feedback the detections to say, this is a false positive, a real positive, a false negative, a real negative. And the same service will learn from it. So the next time it sees a similar behavior, it will call it an issue, or we will continue without issues. That is the identity protection. Okay? Let me give you here a quick demo so you can see how it looks. Here, identity protection. You will see here the users at risk. For example, we have Richard. You can see Richard seems to be at risk from a couple of days ago. Here, we can see what's the risk detected. It's not a sign-in. It's not a user. Then what is it? Here it is. Impossible travel, you see? Identity protection is P2, Richard. It's only P2. We can graph here the impossible travel. And he's also teaching a class this week for Europe, so I'm assuming he's using an RDP or something. So we can actually place them out here. We can grab this one and say, hey, is the detection actually at risk or not? There. We can see here the whole list of details, the detection, and you can see he signed in Newport Beach, Florida. Here, 1053. We can see all the details, and we can say, well, I know this is not an issue. I know he was actually using a remote connection because he's teaching a couple of classes. So I will go here and say, is this an actual risk, folks? What should I do in here? I can say he's compromised and that will block him, or I can say he's not at risk. The next time identity protection sees Richard connecting from that location and simultaneously somewhere in Mexico or somewhere in Europe, it won't trigger the alert, or it will trigger a lower alert. Instead of medium, maybe low. Okay, so what I'm saying here, folks, is that that's why I said this is one of my favorite tools. I think this is one of the best tools that we have. But again, it's only on Premium 2. Okay? So this is our identity protection, folks. It's another of the features we have, or we can include when we are designing for identities. Okay, let's continue here to the next one. That is the access review. When we talk about the access reviews, folks, we're talking about one of those products, if you will, that we can include in our plans. So specific users or the actual users of a service can monitor how often a specific object is consumed. Okay? For example, let's say that each of you will monitor the consumption of Teams on your company. You can create an access review. So you can access you can access the review package and see in a specific period of time which users, how often, and for how long were using Teams. It's pretty easy because everything is logged in Azure. So what we do is that we offer that log, or we give that log to someone or a group of users to determine if there is something going wrong or there is something that seems off. The access review is premium one, the complete access review feature, okay? So be careful. The idea of the review is not only for advanced monitoring, and I would like you to take a note in here. Reviewing, folks, going through an access review can be done by the same user. A real example. On the bank, we used to have users sharing their accounts for specific purposes of consulting. We're talking about a contact center. On the contact center, the call center, we used to have something called help desk user one, for example. And it will be shared by the 3 shifts. We have 8-hour shifts, 24/7. So each shift will use the same user. Instead of using this for advanced security purposes or advanced auditing purposes or investigation purposes, what we did was, okay, we were creating, the users were creating reports to monitor how often they were connecting to the incidents database when they were not online or not on their turn. So it was easier for them to determine, okay, who was doing what? Who took care of this incident? It looks like my user accessed the database registry at 3 p.m. I'm on the night shift. So this incident has been already accessed by someone else. We were doing that manually with an Excel file because there were no access reviews back then. So every time you access the application, you will register an Excel file, and then the next shift user will actually open the Excel and monitor the results. You can give this to the users today. So this could work both ways, for a security management purpose or for a business as usual purpose, folks. A lot of times I get that question, why would you give the option to a user to review their own access? This is the reason why. The access review, folks, will actually be quite helpful for a lot of tracking purposes within the company. Access reviews, as I said, is premium one. Okay? That's another feature that we have in here. Now, when you create access packages and access reviews, you can store them and then you can feed them into logs and create advanced management. That's a different story. I'm just mentioning that so you know that an access review can go beyond the standard monitoring. Okay? So just an FYI. Now, another feature that we can include, folks, and I think this is pretty important, are the service principles. What is a service principle? On premises, I think all of you know, or at least have heard about the Active Directory on premises, right? Has been there since 1996, so that's a long time to not have heard anything about it. Well, on premises, we have something called system accounts, right? On Azure, folks, we have something called the managed identities. A managed identity, it's an identity you can assign to a service, to an application, to a product, so that object can authenticate with it. Real world scenarios that you can understand the idea here. You have two computers. Computer A is exposed to the internet, front end for every user. Computer B is on a private subnet for management purposes. You want every morning that computer B runs a cleaning script on computer A. Okay? Yes, Amit, the session is being recorded. You'll have access to it within the next 10 business days, all of you, without interferences, I promise. So how do you do that? You want computer B to execute a cleaning on computer A every morning. You put a PowerShell script or a batch script or something, and that runs every day, 6 a.m. In a standard scenario, or a, let's say, pretty basic scenario, you will add to the PowerShell script a user and a password that has permissions on computer A, right? Arturo Hamilton at user.com, password ABC, and do something. That's the idea. That's a standard option. On an advanced scenario like Azure, You can assign an identity to computer B. Let's call this computer manager. That computer manager has permissions on computer A. You don't have to use an actual identity on the script. Why? Because the computer B has a user, an identity that has permissions on computer A. You see what I'm saying? I don't have to use variables with users and passwords anymore. I have the chance, I have the option of doing this or managing this complete scenario directly with identities. There are two types of managed identities, folks. Okay, there is a system managed identity and a user managed identity. Okay, what's the difference? Well, you can see the table, right? But let me give you the highlights of the table while you read it. The system identity is created automatically, assigned to a resource, and it's one-to-one. If I create a computer, let me show you here. I'm going to show you, and I'll be back to this slide because I think it's always easier to see this in action. If I create a computer here, how much time we have? We're good. We're good on time. If I create a computer here, I go to management and I click system identity. Azure will create an identity for this new computer. And the life cycle of this new identity will be linked, will be actually attached to the computer. If I delete the computer, the identity gets deleted. Okay? It's one-to-one. I cannot use this identity, this system identity, system managed identity, with any other purpose. I can create my own identities. I can go here, create an identity called, for example, computer manager. You can see here, let's say. Let's call this, for example, all the policies I have, you see. There. Which one can I use? I can recall which. There. I can call this, for example, VM admin. Create, what happened here? Right, space. There. Create a managed identity, user managed identity, and then assign this to any resource I want. Okay, so check this out. I can go to my virtual machine. I can go to manage identities. And I can assign now as a system one, or I can assign one created by me, you see. If I do this and I click on add, whatever permission I give to this will now be available for the rest of the services. Check this out. I can go to a network. Remember, we created one, I think, what we created yesterday. Let's see here, the network. Remember role-based access control? We saw this on Monday. And now I can assign a role. Check this out. The virtual machine manager. I can say owner, manage identity. I can grab here my user manage identity, and you see the one I just created. You see what I'm doing, right? If I have assigned this to the computer will now be an owner of this network. I mean, there might be reasons to do that. I'm not using this as a real example. I'm showing you the process. You can create as many identities as you want and use them for the services to have permissions over the other services. Okay, so that's the idea that we have here. And remember that this only applies for the products. We can assign identities called service principals. Take this note for the exam. Service principals for the applications. Every time you create an application, folks, the application gets the name of a service principal. Okay, it's the representation of an application. The managed identities are for all the other products. When you have a service principal, you can follow the same option. Assign permissions, assign roles, assign responsibilities to an application service principal. Okay? So that's the option we have. Manage identities for service and products, service principals for the applications. Okay? If you have any questions about this topic, please let us know. We're almost done with the content of our day. So we have seen here the Active Directory, business to business, business to customer, the conditional access policies of Premium 1, the access reviews of Premium 1, the identity protection of Premium 2. Okay? You can, the identity, Ankit is asking, if you create a system identity, you need to provide that identity to other resources. No. The system managed identity is already assigned. Remember, a system managed identity is created by Azure, not by you, and assigned to the user. Okay? That's part of the things. Sorry, Ankit. And you have to assign permissions to that identity. That's what you meant, I think. The identity is already there. It's already assigned. You need to give permissions to that identity so it can do something. Okay? That's like the difference here, Ankit. So just an FYI. So this is one of the options that we have, folks. Okay? We have a question. Can you share the event? I think you meant event hub and service bus. Yes, I'll share those tomorrow, Richard, at the end of the class, because I need to put them on a shared drive for you to have access. So I'll share those tomorrow along with the answer to the solutions of the exercises of the week. I'll put everything in one single drive you can download. I'll be sure to do that tomorrow. Okay. So the final topic, folks, to wrap up our day, it's the Key Vault. Okay. The Key Vault could take us 2 hours discussion. Thanks to you, Richard, to go through it. So I'm going to try to make it here simple for you to understand. The Key Vault, first of all, as the name suggests, is a vault, a digital vault with physical encryption if we want, to put 3 things: certificates, secrets, and keys. That's it. What is a key? What is a secret? What is a certificate? Let me give you the explanation of this. A certificate, we all know what is a certificate, right? We can assign a certificate to an application, or we can use the Key Vault as a certificate authority. So anyone who wants to use my applications can get their certificate to trust my connection from it. Easy peasy. That's the easiest one. Remember yesterday when we created our storage account, sorry, I forgot the name, our storage account. Remember that? When we created the storage account, folks, we were given with the option of using our own key to encrypt it, remember? And I said, Microsoft uses their own. If we bring our own key, BYOkey, we will actually have the key managed by us, and Microsoft promises that they won't have the access, right? That's a thing. We can create as many keys as we want to encrypt databases, to encrypt storage, to encrypt computers, etc. Okay? That's the key part. And the certificate, folks, is when we have, the secret is when we have something as a keyword, as a connection string, as an ID, as a variable that we don't want to be part of the text. Think about this example. If you need to connect to a remote, let's say, storage account, what will be better? You put the storage account ID and the URI on a variable inside of the script and the code, or put a URI to a Key Vault that will lend me the secret to use temporarily while I connect and then release it. The URI of the Key Vault will be the one the users will see, but they won't see the URI of the storage account. They won't see the ID of the storage account. If someone manages to unravel the code they will actually go for something like that, right? So it is pretty important, folks, that we decide which one will you use. The Key Vault will give you that extra layer of security. If we are designing based on a principle of security, my friends, the recommendation is to go for a Key Vault. Again, as I've been mentioning a lot of times since Monday, this is not a single correct answer. We have multiple options. Okay, so pretty fast here in the last 5 minutes, let me create a Key Vault so you can see how it looks. I think I have the Key Vault somewhere around here. Yes. Let me go and create. Key Vault. TV demo 305. We go to review and we create. Just a quick tip, folks. Why would you use multiple Key Vaults? If you want performance, for example, if you have a lot of transactions and petitions to the Key Vault for encryption, for accesses, for keys, for certificates, multiple Key Vaults might solve it. Or if you want to have Key Vaults for different type of subscriptions or different layers of subscription, production, etc. Otherwise, one Key Vault might be enough. Okay, so I can go here to my Key Vault, for example. I can create a key. Check this out. I can create a new encryption key. Call this storage account key. You can select the algorithm to encrypt. This is the actual encryption algorithm. You can see the sizes go from 2 to 4 megabytes, or we use different algorithms here. Okay, it's just one, the one you can use. We are going to have this enabled, or we can activate it for a specific period of time. Once we're good, we create the Key Vault, and now on my storage account, I can go here. Let's open the storage account we used yesterday. Here, I can go again to encryption like we were doing yesterday and change the encryption to be my own key. I can select the Key Vault. You can see it here. I can select the key I just created. And easy peasy, we have now the complete storage account encrypted by me. It's no longer a Microsoft encryption, you see? That's the idea. That's another, yes, that's what I was mentioning. Eder is bringing to, as a comment, in an application deployment, you can have one for production, one more for non-production. That's what I was saying. If you have different layers of subscriptions or different layers of the research group, maybe testing, development, quality assurance, production, different Key Vaults are a best practice, right? If you want to test the whole encryption from the development perspective. But again, it's not like there is only one correct option. It depends a lot on the multiple layers you might want to have during a provisioning process. Okay, so you can see it took me what, 3 minutes, and I changed the encryption from Microsoft to mine. I am the owner of the Key Vault now, and on the user agreement you sign with Microsoft signs with you when you accept the subscription, it states that you are not actually Microsoft is not accessing anything that you have on your Key Vault. Okay. So this is it, folks. This is our last topic of the day here. On this second exercise, you will have to create based on accounts, how the users will access the applications and the solutions. So you have here to put this stuff wherever it's supposed to be. Here, I should skip this too because that's the solution. And I'll share the solution with you tomorrow. Remember, tomorrow I'll be sharing all the solutions, okay? Not only today's. All the solutions of the week will be available for you tomorrow at the end of the class. That's the plan for tomorrow. And tomorrow we will also have 2 lessons, 2 more modules, and a small link for a couple of extra materials I got together, so you can see the videos and differences of the service laws. That's the complicated one. Okay? Issues, comments, or complaints, folks. We're done for the day. we have 2 more minutes if you have any questions. Sorry about the inconvenience we had. It was a little bit of a disruption we experienced at half of the day, but it's solved now, and we're expecting not to have it again tomorrow. Again, this was a thing with our platform, not your connections or mine, just for you to know. And I don't know if there is anything else you would like me to discuss before we are done. No, you cannot have access to the slides, but you have all the material of the slides on the learning pad. Okay? If you put AC305 Microsoft on your Bing search, the first result you get, you have all the slides, not the slides, the content of the slides in there as well. Okay? What are we doing on Friday, Vlad? On Friday, we have an exam prep. It's a 2 hours discussion. Thanks to you, Max. A 2 hours discussion about what to expect from the exam, like types of questions, duration, tips, and a summary of all the topics you'll see. Okay, what you might expect from all the topics. So it's like an hour and a half discussion about the actual exam experience. That's the idea. Okay, so thank you, Justin. Yeah, I think they figured it out from there. Thank you very much. Thank you very much for sharing that. So I hope that clarifies there, Vlad. Any other issues, questions, things, folks, that you might want to discuss? We still have a couple of minutes. If you don't have any more questions, you can now log out. We're going to end the session in a minute, and I'll see some of you maybe on the labs. Okay. Stanley, the learn modules that are currently viewed are the complete list of modules we'll discuss today. No, there are. We cover 8 modules during the week. Sorry, 6 modules during the week, and you have other 6 modules that you have to cover on like homework. I'll show you all these modules, all the list on Friday on the exam prep. Yes, if you want one and we have the time, bring them on. And if we don't, you have my email. I'm gonna share my email and my LinkedIn again, so we can discuss it like pretty specifically, like one-to-one if you want to. If we don't have the time, just in case. Folks, the session will end in a minute, actually in 30 seconds. Thank you very much. Thanks to all of you. Again, apologies for what we have. So the videos will be available within the next 10 days in your portal. The portal you use to access the session, you'll see a module for the recordings. So again, folks, thank you. Thank you, everyone. I hope you have a great rest of your day. And I'll see you tomorrow for the last day of theory and Friday for the exam prep. Thank you, my friends.